Hey kiddos, today we are going to look at section 7.3 and what we're going to do is solve some radical equations. Hope you're ready for some fun. Remember radical symbols? We can have square roots, we can have cubic roots, we can have fourth roots, and if you are asked to solve something, what that means is you want to isolate the variable. So you want it to be x equals or m equals, whatever your variable has to be. When you are solving for radical equations, these are the steps that you want to follow. Step 1, isolate the radical on one side of the equation. So what that means is you need one side of the equation to be just the radical and what's underneath. Step 2, raise each side of the equation to the same power as whatever the index is. So here we'll have to take both sides to the power of 3. This is an unwritten 2, so we'll have to square both sides. Then what will happen is your radical will cancel. And so you'll be ready to move on to step 3, solve the resulting equations. And you're going to use techniques that we have been doing all year for solving equations. Okay? So we're going to go ahead and just go through 6 examples together. So if I look at example A, step 1 is you want to isolate the cubic root of x. That means this minus 2 needs to go to the other side. To move a minus 2, remember you have to add 2. What you do to one side, you do to the other. Minus 2 plus 2 cancels. This side is a cubic root of x equals. This was 0 plus 2, so you get a 2. Step 1, complete. Step 2, raise each side of the equation to the same power as whatever the index is. My index is a 3, so I need to take both sides to the power of 3 because a cubic root and a cube cancels. X is alone, which is what you want because you're solving, meaning isolate the variable. 2 to the power of 3 means 2 times 2 times 2. 2 times 2 times 2 is 8. Done. Okay, here's the next one. Step 1, isolate the radical. So I need the square root of x to be all by itself. To move a minus 4, you got to add 4. This side is a square root of x. 0 plus 4 is 4. To cancel a square root, you need to take both sides to the power of 2 because a square cancels a square root. X is isolated. 4 to the power of 2 means you have 2 4s. 4 times 4 is 16. Moving on. I need to isolate the radical, meaning just the radical and what's underneath. I have 2 things that I need to move over. So remember, you always want to move whatever's on the same side as your variable, or in this case, we're looking at a radical, but not connected. Meaning, I need to move my negative 1 to the other side. To undo a minus 1, you add 1. What you do to one side, you do to the other. On this side, I would have 3 times the square root of x plus 4. This side had an 8. When I added the 1 over, now it's 9. This is not isolated yet. I need just the symbol and what's underneath, so I need to get rid of this 3. This is 3 times the square root. In order to undo multiplication, you do the opposite operation, which is dividing. 3 cancels a 3. So square root of x plus 4 equals 9 divided by 3 is 3. Okay, so that is step 1. So far what we've done is we isolated our square root and what's underneath. If you go to step 2, raise each side of the equation to whatever the index value would be. This is a square root, so I'd raise them both to the power of 2. If you square a square root, it cancels. X plus 4 is no longer underneath the symbol. 3 squared, that means you have 2 3s. So 3 times 3 is 9. Last step, I want x by itself, so I need to undo a plus 4, minus 4 to each side. 9 minus 4 is 5, and you're done. 3 more, and then you'll have some questions out of the book to practice the same skill, but on your own, just to make sure you've got it. Looking at example D, step 1, we want to isolate our radical term. I need to move plus 5. To move plus 5, you have to minus 5. This side is a cubic root of 4x. If I had 7 and now I'm minus 5, it's down to a 2. Step 2, To cancel a cubic root, you need to go ahead and take both sides of the power of 3. A cubic root is canceled by a cube. 4x, that was your radicand. It is no longer underneath the symbol because the symbol has been canceled. Equals 2 to the power of 3 means 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. Last step, solve. I want x by itself. Right now it's 4 times x, so I need to divide both sides by 4. 8 divided by 4 is 2. You're done. 2 more. Now what happens if you get this? Okay, if you have 2 radicals, ideally what you need to do is have 1 radical on each side. So what I'm going to do, this is minus a square root of x plus 1. So if I add it to the other side, or what you do to one side, you always do to the other. Minus a square root of x plus 1 plus a square root of x plus 1. This side, what I have remaining is just the square root of 2x equals 0 plus the square root of x plus 1. When you add anything to 0, what you get is the value that you were adding, even if it's a full square root of something. So what I did is I took this negative or minus the square root of x plus 1 and I plopped it over to the other side. And now they're both positive radicals. I have 1 on each side. So technically, this passes our step 1. This side is just a radical in what's underneath. This side is just a radical in what's underneath. So step 1 is complete. Step 2, what we have to do is take both sides to the power of whatever this index is. These are square roots. So I need to square both sides. Check this out. Square cancels a square root, so 2x is out of your square root symbol. This side is just 2x. Square cancels a square root. I have x plus 1. Here is my new equation. I'm just going to slide this on over. I'm not changing anything, just giving myself a little bit more room. Okay? I need x by itself. Beginning of the year, we talked about this. You can't have x's on both sides of the equation. This is a 1x. So what we practice doing is getting rid of the smaller of the two. So I have 2x and 1x. 1x is smaller, so I'm going to move it to the other side by doing the opposite operation. 1x minus 1x, that cancels. This side was 2x is minus 1x. I just have 1x left. This side is only a 1, so x equals 1. This is as hard as it's going to get. As you're working through the assignment, there will be a couple where you have to take a radical and you got to move it to the other side. Then when you go ahead and take both radicals to whatever the exponent needs to be, if it's a cubic root, it'll be a 3. If it's a fourth root, it'll be a 4. Both signs will cancel, and then you'll just have an equation to solve. Okay, so if you get to 1, and let's say it's a little bit tricky, you can always come back and rewatch this video as well. One more example. Step 1, I need to isolate the fourth root of 8x plus 9. On the same side as that but not connected is a minus 12. So my first step, I'm going to add 12 to each side. So 4 times the fourth root of 8x plus 9 equals 0 plus 12 is 12. This is not isolated yet because it's 4 times this. I need to get rid of the 4 because this is multiplication. I need to divide. This is a fourth root of 8x plus 9. 12 divided by 4 is 3. Okay, so we're done with step 1. This side is just your radical and what's underneath. Step 2, raise both sides to the power of whatever the index is. The index was a 4, so that's why I'm taking it to the power of 4. A fourth root cancels a power of 4. 8x plus 9 equals 3 to the power of 4 means you have 3 times 3 times 3 times 3. That's 81. Now I'm just doing a basic two-step equation. On the same side of the equation as x, not connected is a plus 9. Go ahead and minus 9. What I have left is 8x. 81 minus 9 is 72. We're not done because you have to solve. X has to be alone. This is 8 times x. Divide both sides by 8. 72 divided by 8 is 9. And we just practiced solving radical equations. Have a great time doing your book questions, practicing on your own. I hope you enjoy it. Again, if you get stuck at all, you can replay this video to help you out. Have a great day. Talk to you soon.